Imagine you are managing like a small business. Let's say it's a boutique online retail shop selling specialized outdoor gear.
Oh, okay, yeah. That's a tough market.
Right. You have limited capital, a tiny team, and you are up against these massive corporate competitors.
Oh, the giants.
Yeah, exactly. And you need to know exactly what those competitors are pricing their products at, like every single day, just so you can adjust your own pricing to stay competitive.
Which is a nightmare to do manually.
Right. Doing this manually means you are sitting down with a cup of coffee at, I don't know, 6 in the morning. You open up 20 different tabs on your browser.
Sounds exhausting already.
It is. You're clicking through competitor website after competitor website, trying to find the specific sleeping bag or the specific tent, then copying the price and pasting it into a document.
And by the time you finish, half those prices might have changed again.
Exactly. It would take your whole morning, every single morning. But what if you had, like, a digital assistant?
Oh, that would be nice.
Right. What if you had a tool running in the background that could automatically scrape all that data from across the web, compile it into a neat little report, and tell you exactly how to price your own products to win the market that day, all before you even pour your first cup of coffee?
I mean, honestly, it sounds like an incredibly expensive luxury.
Yeah.
Or maybe like something only a massive tech conglomerate could afford to build. But the reality of modern business is that this kind of automation is completely accessible to, well, almost anyone.
It really is. It's not science fiction at all. That process is called web scraping, and it is a completely standard business practice powered by the core topic we are getting into today.
Yeah, it's foundational now.
So, welcome to the deep dive. Today, we are looking at the digital shift that every future manager, every entrepreneur, and really every business professional needs to understand.
Absolutely.
We are pulling insights directly from Module 25 of the Connect Master, Management Information Systems series by Richard Tedman and Casey Wilhelm. This is the 2026 edition from McGraw-Hill.
Which is packed with great stuff.
So it really is.
Yeah.
And we've custom tailored this deep dive for the students at the Dr. Stampak College of Business at Tarleton State University.
Go Texans, right.
Yeah, exactly. But also, you know, any working professionals and insanely curious learners joining us today, we are figuring out why companies are stepping out of the traditional spreadsheet and into Python.
Yeah, and this is such a natural progression from where we were in the previous module.
Right.
If you've been following along with the course, you know that in Module 24, we looked really closely at data analysis using Microsoft Excel.
Excel, the absolute workhorse of the entire global business world.
It truly is. I mean, in that previous discussion, we explored how Excel acts as this incredibly versatile powerhouse for managing business data.
Yeah, we covered a lot.
We did. We looked at tools like VLOOKUPs, XLOOKUPs, and index match. Those are the essential functions you need when you have to connect, disparate pieces of data.
Right, like if you have a massive list of, say, 100,000 transactions,
yeah,
and you need to find one specific customer's order history just by typing in their unique ID number. Yeah. Excel handles that beautifully.
It does, yeah. We also looked at the what-if analyses, specifically things like the Scenario Manager and the Goal-Seek tools.
Oh, I love Goal-Seek.
It's amazing. They are incredible for forecasting outcomes. Say you are that boutique outdoor gear shop, and you want to know exactly how many premium sleeping bags you need to sell to hit a specific 15% profit margin for the quarter.
Right.
Goal-Seek takes all your variables and literally runs the math backwards to give you that target number.
Which is wild.
Yeah. And for the heavier lifting, we touched on the Excel Power Tools, Power Query, Power Pivot, and Power BI, which allow managers to handle larger data sets and build out those really engaging interactive dashboards.
So let's unpack this right away. If Excel is so phenomenal and it has all these advanced power tools bolted onto it, why are we dedicating an entire deep dive to a programming language?
It's a fair question.
All right, like, why do we need Python?
That is the pivotal question for anyone entering the business world today. I mean, Excel is fantastic for structured, medium-scale data. It gives you this beautiful visual grid that humans understand intuitively.
Yeah, we like boxes.
Exactly. But eventually, as a business grows, they hit a wall.
I imagine it's a data wall.
A massive one, yeah. When your data volume absolutely explodes, and we're talking about moving from tens of thousands of rows to millions or tens of millions of rows, or, when your daily tasks become highly complex and repetitive, manually clicking through spreadsheets becomes a massive liability.
Oh, sure.
Your computer freezes, the program crashes out of nowhere, or worse, a simple human error like a bad copy-paste ruins an entire financial model without anyone noticing.
I have definitely done that.
We all have. That fundamental limitation of the spreadsheet sets the perfect stage for today's topic. It's about stepping out of the grid.
Stepping out of the grid and into programming. I love that. But before we take that step, a quick reminder for you listening. Please take a second to like, subscribe, follow, share, and comment on this deep dive.
It really helps.
It does. It really helps you stay updated with the course material and connects you with this awesome community of business students and professionals. Think of it as like high-fiving your study partner in the library.
It makes a huge difference in keeping the discussion going. Absolutely.
Okay, let's get into the mechanics of this.
Yeah.
To understand why businesses are moving beyond Excel, we first have to understand what it actually means to program a computer.
Right.
Because I think when a lot of business majors hear the word programming, they immediately picture a hacker in a dark room.
Drinking energy drinks.
Yes. Typing glowing green code on a black screen. It feels intimidating and, frankly, entirely disconnected from like supply chain management or marketing strategy.
That stereotype is persistent, I know. But in the modern business environment, programming is incredibly practical, and it's much more accessible than people think.
Yeah, so
Well, to demystify it, we just need to look at what a computer actually is. At its core, a computer is just a mechanical or electronic device that stores, retrieves, and manipulates information at incredibly high speeds.
And with total accuracy.
Exactly.
But it's fundamentally dumb, right? Like
Yeah.
it doesn't do anything on its own.
That is the perfect way to phrase it. It is a highly capable, incredibly fast, but entirely dumb machine. Without human intervention, a computer just sits there waiting.
Just a really expensive paperweight.
Pretty much. It acts purely by following coded instructions. Those instructions are what we call programs. So programming is simply the act of writing the explicit step-by-step instructions that tell the computer what to do with the data it has.
And one of the most popular ways to write those instructions right now, especially in data analysis, is Python.
Yes, and Python has a really interesting history. It was introduced back in 1991 by a developer named Guido van Rossum.
Oh, 1991, so it's been around a while.
It has. His primary goal was to create a language that was incredibly simple, highly readable, and intuitive for humans, but just as powerful under the hood as the highly complex traditional programming languages like C++ or Java.
Well, it clearly worked. And Python is currently ranked the third most demanded programming language globally by corporate recruiters.
That's huge.
It's a massive signal for anyone studying business or management. But what makes it so special? Why are recruiters looking for this specific language over everything else?
Python's dominance comes down to a few key factors. First, it is a multi-purpose language. You can use it to build a website, automate a simple task, or run an advanced artificial intelligence model.
Wow. Okay.
Second, it is open source.
Let's define open source for a second. That means no one company owns it, right?
Correct. It is not locked down by Microsoft or Apple. It is built, maintained, and constantly improved by a massive global community of developers who share their work for free.
Which is awesome.
It is. But the real secret weapon, the thing that makes Python so indispensable in business, is its heavy reliance on libraries and modules.
Okay, I want to explore this concept of libraries because I think this is where the light bulb goes on for a lot of people.
Yeah, it's the game changer.
I actually came up with an analogy when I was reviewing the module materials. Let's test this out.
Oh, I'm ready. Let's hear it.
I think of Python libraries like a high-end meal kit delivery service.
Okay, I'm with you.
Let's say I want to cook an incredibly complex, authentic Italian pasta dish.
Yeah.
If I had to do it from absolute scratch, which is the equivalent of writing basic computer code from zero, I'd have to go to a farm, harvest the wheat, mill it into flour, mix the dough, roll out the pasta, grow the tomatoes, harvest them, crush them, and boil them down for hours.
That sounds exhausting.
It would take months to make one dinner. That is what traditional programming can feel like if you are building every single mathematical function yourself.
Right, it is incredibly tedious and prone to error.
Right. But Python libraries are like someone delivering a meal kit to your front door.
Yeah.
It gives you the pre-measured premium ingredients and the exact step-by-step recipe.
Oh, I like this.
You don't have to know how to grow wheat. You just open the box, follow the instructions, and jump straight to cooking the meal. In business, you just jump straight to cooking the solution.
That is a brilliant analogy, and it captures the mechanics perfectly. A Python library is exactly that, a collection of related programming modules containing precompiled bundles of code.
Right?
The heavy lifting, the complex mathematics, the intricate algorithms, all of that has already been written, tested, and perfected by someone else in the open source community.
So you don't have to reinvent the wheel.
Exactly. You don't need to write 1,000 lines of code to run a statistical model. You just import the library, pull the meal kit off the shelf, and use the pre-built functions.
So if I'm a student at Tarleton State getting ready to enter the job market, what are the specific meal kits or libraries that I need to know about?
There are 4 major ones that are foundational to business data analysis. First, for data mining and data manipulation, you're going to hear about Pandas and NumPy.
Pandas and NumPy, what do they actually do under the hood? Like, explain them to me as if I'm 5.
Okay, think of NumPy, which stands for Numerical Python, as the ultimate calculator.
Okay, ultimate calculator.
Right. If you have a data set with millions of numbers and you need to perform complex, heavy mathematical operations on them simultaneously, NumPy is the engine that does that math at lightning speed. It handles massive arrays of numbers efficiently.
Okay, so NumPy is the math engine. What about Pandas?
Pandas is all about structure. If you think about an Excel spreadsheet with rows and columns, Pandas allows Python to create a similar structure in its memory called a data frame.
A data frame.
It takes messy, unstructured data and organizes it, cleans it, and filters it so that you can actually understand it. Pandas is what you used to say, take this massive pile of customer data, filter out anyone who didn't make a purchase in the last year, and group the rest by their zip code.
Got it. So Pandas organizes the data, and NumPy runs the heavy math on it.
Exactly. Then, once you have analyzed the data, you need to show it to someone. That brings us to the next 2 libraries, Matplotlib and Seaborn. These are your visualization libraries.
So these are the libraries that actually draw the charts and graphs.
Yes. Matplotlib is the foundational library that plots the data into standard charts, bar graphs, line charts, scatter plots.
The basics.
Right. And Seaborn is built on top of Matplotlib. It's used to make those visuals highly attractive and statistical. It handles complex heat maps and color-coded distributions that look polished enough for a boardroom presentation.
This is a huge relief, honestly. So if I'm a manager, I don't necessarily need to be a software engineer who can build NumPy from scratch.
Not at all.
I just need to know that Pandas and Seaborn exist. That way, I can tell my data team, hey, let's use Pandas to sort through these 2 million customer records, and then let's use Seaborn to map it out, rather than trying to force Excel to do it and watching the office computers melt down.
That is the crucial takeaway. Knowing these tools exist allows managers to deploy powerful solutions quickly. You are managing the process and asking the right questions, not necessarily building the engine from scratch.
This brings us to a massive question: the why and the where.
Let's hear it.
We know what Python is now, and we know about its libraries. But how is it actually deployed across the different functional areas of a business? Because theory is great, but practice is what gets you hired.
Very true.
Let's say I graduate and land a job in marketing. How am I, or my department, using Python?
Well, if we look at sales and marketing, Python has completely revolutionized how digital campaigns are run. It automates almost everything, and one of the foundational ways it does this is through APIs.
APIs.
Yeah.
Application Programming Interfaces. I hear that acronym thrown around constantly in tech and business, but I feel like people rarely actually define what it is.
Oh, it's true. People use it like a buzzword.
Walk me through the mechanism of an API.
Let's use another analogy. Imagine you go to a restaurant. You sit at the table with a menu, and the kitchen is in the back. The kitchen is the system that has all the food, or in our case, the data.
Okay, I'm tracking.
You, the customer, want the food, but you don't go into the kitchen and start cooking.
Right, that would be chaos.
Complete chaos. So you need a messenger to take your specific request from the menu to the kitchen, and then bring the finished plate back to your table. The waiter is the API.
The waiter's the API. I like that.
An application programming interface is just a set of rules that allows one software program to talk to another software program and request specific data.
Okay, so how does a marketing team use that waiter?
Let's say your company just launched a new running shoe. You want to know what the public thinks about it. Instead of having an intern manually search X, Facebook, Yelp, and Instagram for mentions of your shoe, your company uses a Python script.
To do it automatically.
Yes. This script connects to the APIs of those social media platforms.
It hands the waiter the request.
Exactly. It says, bring me every public post from the last 24 hours that mentions our new shoe. The API brings back thousands of text posts instantly. Then the marketing team uses another Python library to run a sentiment analysis on all that text.
Sentiment analysis. It can tell if the posts are positive or negative.
Yes. The algorithm scans the text for keywords love, hate, uncomfortable, fast, and instantly generates a report telling you the overall public sentiment. You know in real time if the product launch is a success or a PR disaster without a human reading a single tweet.
That is incredible, and that leads right back to the web scraping example I used in the opening hook, the digital assistant checking competitor prices. Web scraping doesn't always use an API, right?
Good catch. No, it doesn't. Sometimes a competitor's website won't have an API. They aren't going to build a waiter to hand you their data on a silver platter.
They want to hide their prices from you.
Exactly. So you have to go get it yourself. Web scraping is the automation of extracting large volumes of data directly from websites.
Let's break down the mechanics of web scraping, because it sounds like magic. How does the script actually read a website?
The process outlined in the industry standard workflow is very specific. First, you identify the target URL. Let's say it's a competitor's page for a specific tech.
Okay, URL identified.
Second, you identify the exact data you want, which is the price. Third, and this is the mechanical part, you inspect the page's code.
Okay, explain that. What does inspecting the code mean?
A website might look beautiful to you with pictures of tents and nice fonts, but to a computer, a website is just a skeleton of HTML code. When you inspect the code, you are looking at the raw tags that build the page.
So not the pretty stuff.
No, Python doesn't look at the picture. It scans the HTML skeleton. It looks for the specific rib bone where the price is hidden. Usually the price is wrapped in a specific tag, like a span class called product price.
Oh, I see. So the script doesn't need to understand what a tent is. It just needs to find that specific tag every single time.
Exactly. So the fourth step is writing or using your Python code to tell it, go to this URL, ignore the pictures, ignore the text, find the tag called product price, and grab whatever number is inside it.
That's step 4.
Yes. The fifth step is the script extracting that data. And finally, the sixth step is compiling it into a report or a visualization.
That is so powerful for things like daily price comparisons.
Yeah.
I can also see how R&D research and development would use this. They could scrape a competitor's entire catalog to see what new features they are listing on their products, all automated.
Absolutely. It is a massive competitive advantage. And beyond scraping and APIs, marketing relies heavily on analytics and SEO.
SEO, search engine optimization.
Right.
How does Python help with SEO? I thought SEO was just about writing good blog posts with the right keywords.
Writing good content is part of it, for sure. But the technical side of SEO is massive. Search engines like Google rank websites based on technical health. Python scripts act as custom web crawlers.
Wait, I need an ELI 5 on web crawler. What is that?
A web crawler is basically an automated script that browses the internet in a methodical, automated manner. It crawls from link to link. A marketing team can deploy a Python crawler to scan their own company's entire website, thousands of pages in a matter of seconds.
What is it looking for, though?
It checks word counts to ensure pages aren't too thin. It verifies that target keywords are present. It ensures all the meta tags, the hidden descriptions that search engines read, are correct. It even flags images that are missing alt text, which is crucial for accessibility and SEO.
Oh, wow.
Yeah, if a human had to click through 1,000 pages to check image tags, it would take weeks. Python does it while you grab a coffee, increasing your non-paid visibility on search engines almost instantly.
Okay, so marketing is fully supercharged by Python. Let's pivot to finance, because finance is all numbers anyway, so I imagine Python is deeply entrenched there.
It is the backbone of modern finance. Python is central to both quantitative and qualitative financial processes.
Okay, so big picture first.
At a high level, it's used for massive analytics of financial data. We're talking portfolio management, risk assessment, historical market trends, but it's also heavily used in banking and fintech.
Fintech, financial technology. Like those apps on my phone that automate my investing, or the complex payment processors that handle online checkouts.
Yes, exactly. Let's look at a concrete example. Fraud detection in a payment processor. Let's say you swipe your credit card at a coffee shop in Paris. The bank doesn't have a human sitting in a room looking at your transaction history to decide if you are really in Paris.
Right, that would take way too long. I'd be standing at the register forever.
Exactly. Instead, the transaction hits a Python-driven predictive model. In milliseconds, the algorithm pulls your past data, compares it to known fraud patterns, runs a complex probability matrix, and decides whether to approve or decline the charge.
In milliseconds.
Yes. Python automates the entire back end of banking, insurance, and payment systems because of that speed.
And I imagine it's using cryptocurrency as well.
Heavily. Crypto markets are incredibly volatile and operate 24/7. Humans can't monitor that effectively. Python scripts pull real-time API data from crypto exchanges, analyze the minute-by-minute fluctuations, and use predictive models to make automated trading decisions before a human could even open the app.
That makes perfect sense. Now, here's a functional area that I think causes some anxiety among students.
Oh, I know where this is going.
Accounting. I hear this fear a lot from business students. Will AI and programming take accounting jobs?
Yeah, that comes up a lot.
Right. If Python can do the math in milliseconds, what does a human accountant actually do?
That fear is very common, but it's fundamentally misplaced. Accountants aren't being replaced by Python. The smart ones are turning to Python to increase their own efficiency and value.
How does that work in practice? Let's say I'm an accountant at a mid-sized firm.
Well, traditional accounting inherently involves highly time-consuming, repetitive, and redundant tasks. Think about data entry, matching massive ledgers, basic reconciliations between bank statements and internal books.
Right, the grunt work.
Historically, an accountant might spend 40 hours a week just getting the data to match up.
Staring at two spreadsheets trying to find the missing 10 cents.
Exactly. It's miserable work. But by using libraries like Pandas and NumPy, an accountant can write a script that takes the bank's data dump, cross-references it with the internal ledger, flags the discrepancies, and reconciles the rest automatically in about 5 seconds.
So they just deleted 40 hours of their own work. Doesn't that mean they get fired?
No, it means they finally get to do their actual job. It frees them up to do higher-level analysis, strategic forecasting, complex tax planning, and deep problem-solving.
Oh, I see.
They take the reconciled data and go to the CEO and say, based on these cash flow trends, we can afford to acquire our competitor next quarter. Python becomes a tool that elevates the accountant's role from a simple data entry clerk to a strategic business advisor.
I love that. Learn Python so you can be the strategic advisor, not the clerk. That is a great mindset. Okay, this leads us perfectly into the heavyweight matchup.
Ding ding!
We have established that Python is this incredibly powerful, magical tool that automates everything. So the logical question for a manager is, should we just delete Microsoft Excel from all our corporate computers? Why pay the licensing fee if Python is free and better?
You should absolutely not delete Excel. And this is a critical distinction for a future manager to understand. It is never about finding one tool to rule them all. You need to know which tool to pick for which specific job.
Okay, let's break down their general limitations in their environments first.
Right.
Let's put Excel in the ring first. What is its environment and where does it fall short?
Well, Excel operates on a very simple graphical user interface, a GUI.
Meaning you can see the grid, you can click on the cells, you can drag things around, it's visual.
Right. It's incredibly intuitive. Anyone can open Excel and start typing numbers, but its limitations are largely about scalability and stability. As your data volume increases, Excel begins to struggle immensely, it slows down, it crashes.
The dreaded spinning wheel of death when you try to sort a large column.
Exactly. Plus, because it relies on human interaction, there's a massive risk of syntax errors. People manually copying and pasting data between sheets inevitably make mistakes. And finding that mistake in a massive spreadsheet is a nightmare.
It's like finding a needle in a haystack.
Yeah. There are also potential security risks if sensitive financial data is just floating around in unencrypted Excel files on someone's local desktop.
Okay, so Excel struggles with size and human error. What about Python? What are its limitations? Because it can't be perfect.
Python's main limitation is the environment and the steep learning curve. You do not get a friendly visual grid. You operate in an IDE, an integrated development environment, or a text editor.
Explain an IDE to me. What does that actually look like on my screen?
Imagine a digital workbench. On one side of the screen, you have a blank text document where you type your lines of code. On the other side, you have a terminal that spits out the results or tells you where your code is broken.
So you are literally just staring at text. There are no buttons to click to make a pie chart.
Correct. You have to type the command to generate the pie chart. It is a much steeper learning curve and a less friendly, highly technical interface for someone who has spent their whole career dragging and dropping in Excel.
Let's compare them on data analysis and automation.
In Excel, your data analysis relies on built-in functions, pivot tables, and the analyze data feature we discussed in the last module, which is great because it lets you use natural language queries. Automation in Excel relies primarily on VBA, Visual Basic for Applications.
The VBA is kind of outdated, isn't it?
It is clunky, and it has severe limitations in what it can automate outside of the Microsoft ecosystem. It can't easily talk to external websites or advanced APIs. Python, on the other hand, uses those libraries like Pandas for complex statistical analysis.
So it's way more flexible.
Much more. It is far better for managing entire data pipelines, performing complex, multi-step algorithmic calculations, and deploying machine learning.
Okay, we need an ELI 5 on machine learning before we go further. I hear it everywhere.
Think of traditional programming like writing a recipe. You tell the computer exactly what to do. If the customer buys a tent, send them an email about sleeping bags. You write the rules.
Okay.
Machine learning flips that. Instead of writing the rules, you feed the computer a massive amount of historical data, thousands of past customer purchases, and you say, figure out the rules yourself.
Wait, really? It writes its own rules?
Yeah. The algorithm learns that people who buy tents often buy sleeping bags, and it writes its own rules to predict future behavior. Python is the dominant language for building those machine learning models. Excel simply cannot do that natively.
That makes perfect sense.
Yeah.
So Excel is great if I need to whip up a quick descriptive chart for a meeting this afternoon. Python is for when I need an automated machine learning system to analyze data every single day without my input.
That's a great summary. Now let's look at scalability and connectivity. Excel is fantastic for small to medium data sets, but it literally has a hard limit built into the software.
It's roughly 1 million rows, right?
Yes, 1,048,576 rows to be exact, which sounds like an infinite amount of data to a student. But think about a national retailer like Target. They track every single item scanned at every single register across the country every second of the day. 1 million rows of data is probably generated before lunchtime.
You try to open that in Excel, your computer will literally catch fire.
It will just crash. Excel is good for basic SQL database connections.
Wait, ELI 5 for SQL really quick?
SQL stands for Structured Query Language. It's essentially a highly organized digital filing cabinet for massive amounts of data. Excel can connect to that cabinet and pull small folders out. But trying to stream large, continuous flows of data from a SQL database into Excel is a recipe for a crash. Python, on the other hand, offers virtually limitless scale.
Because there's no visual grid to render on the screen.
Exactly. It doesn't have to draw 1 million little boxes on your monitor. It just processes the raw data in the background using your computer's memory. It can easily merge data from multiple massive tables. And Python works incredibly efficiently with cloud-based data sources through what are called containerized notebooks.
Containerized notebooks.
Yeah.
That sounds very technical. Break that down for the business major who just wants to do their accounting homework.
Think of a standard Word document. You write text, maybe paste a picture. A digital notebook in Python, like a Jupyter notebook, is a document where you can write normal text explaining your thoughts. But right below the text, you can write a block of Python code, hit a play button, and the code actually runs right there on the page.
So it's interactive.
Right, pulling data from the cloud and spitting out a chart right in the document.
That sounds amazing.
It is. And the containerized part just means that this notebook runs in a secure, isolated little bubble, a container on the cloud. It doesn't rely on how fast your personal laptop is, and it won't accidentally delete files on your hard drive because it's locked in that container. It streamlines importing, analyzing, and sharing massive data sets securely.
I think I have the perfect analogy to summarize this entire Excel versus Python debate. Tell me if I'm on the mark here. Excel is like a highly capable Swiss Army knife. It is visual, it is quick, it is intuitive. You can pull it out of your pocket to fix an everyday problem, cut a loose thread, or open a bottle. Anyone can use it.
I like where this is going.
Python is like building an industrial car manufacturing plant.
Exactly.
It takes a lot more time, capital, and specialized expertise to build the factory line. You have to design the conveyor belts and program the robotic arms. But once you turn the machines on, it can process millions of units automatically without you having to lift a single finger.
That is an incredibly accurate way to view it. And as a manager, you wouldn't commission a multi-million-dollar factory line just to whittle a single piece of wood for a hobby project.
Right.
Conversely, you wouldn't try to use a Swiss Army knife to manufacture 10,000 cars a day. You need to know when to deploy the quick, visual tool and when to invest in the automated, scalable infrastructure.
Okay, so whether a company is using the Swiss Army knife of Excel or the factory line of Python, they still need a blueprint. A factory is useless if you don't know what you're trying to build.
Very true.
They need a structured approach to handle all this information. Which brings us to the underlying frameworks of analytics and ecosystems. Let's start by defining data analytics itself. as it's presented in this module?
The module defines data analytics as the process of investigating raw data to uncover trends and answer specific business questions. And importantly, it breaks this down into 3 distinct tiers or types of analytics: descriptive, predictive, and prescriptive.
Okay, let's explore these tiers. Let's start with descriptive analytics.
Descriptive analytics looks entirely at historical trends. It answers the fundamental question, what happened? So if you are looking at your return on investment for the last quarter, or generating a summary report of how many units sold during a Black Friday event, that is descriptive.
It's like looking in the rearview mirror of a car. It tells you exactly where you've been, but it doesn't help you steer.
That's a great metaphor. Because it's in the rear view, it can't tell you what's coming next. For that, you need the second tier, predictive analytics. This answers the question, what might happen next?
So if descriptive is the rearview mirror, predictive is looking through the windshield to see where the road is curving ahead.
Yes. And it achieves this by using probability, statistical modeling, and that machine learning we discussed earlier. It takes the historical data from the rearview mirror, finds the patterns, and projects them forward to forecast future outcomes.
And then we have the third tier, which sounds like the ultimate goal, prescriptive analytics.
Prescriptive is the most advanced form of analytics. It doesn't just tell you what happened, and it doesn't just tell you what might happen. It determines the best course of action. It answers the question, what should we do about it?
Going back to the car metaphor, prescriptive analytics isn't just the windshield. It's the GPS navigation telling you to swerve left to avoid the traffic jam ahead.
Exactly. It prescribes the solution.
Can we dive deep into some concrete examples of prescriptive analytics? Because that sounds like the holy grail for any corporation.
It absolutely is. Let's look at 3 specific examples highlighted in the industry standards covered by the module. First, airlines. Airlines operate on razor-thin margins, and fuel costs are their biggest variable expense. They don't just use data to predict that fuel prices will rise in Europe next week.
Right, predicting it doesn't save the money.
Exactly. Their prescriptive analytics systems track global fuel prices, weather patterns, and flight schedules. And the system actually prescribes exactly when and at which specific airport a particular plane should fill its tanks to minimize costs across the entire fleet. The system tells the manager, buy 10,000 gallons in Atlanta today, but don't refuel in London tomorrow.
Wow. That is directly impacting the bottom line. What's another example?
Healthcare organizations. They use prescriptive analytics to monitor flu strains and patient symptom reports globally. The system predicts where an outbreak will peak, and then it prescribes optimal resource allocation.
So it moves stuff around before it's needed.
Yes, it tells the hospital network, ship 500 extra ventilators to the Dallas region immediately before the outbreak hits its peak there next week.
It's literally saving lives by moving resources ahead of time.
Yeah.
And the third example.
Cybersecurity. This is perhaps the most critical application right now. Cybersecurity firms analyze network traffic for threats, but cyber attacks happen in milliseconds. If a system just predicts an attack and sends an email alert to a human engineer, it's too late. The data is already stolen.
The human is the bottleneck.
Exactly. So they use prescriptive analytics. The system detects the anomaly, predicts the attack vector, and autonomously prescribes and executes automated defensive protocols. It locks down specific servers, changes firewall rules, and isolates the threat before the human engineer even finishes their cup of coffee.
The system isn't just saying, hey, you might get hacked. It's saying, you were about to get hacked, so I already locked these 3 specific doors and rerouted the traffic. That is incredible.
It is. Now, all of this analytics from descriptive up to prescriptive has to happen somewhere. It happens within what we call a data ecosystem.
An ecosystem. I hear that word and I think of a rainforest or a coral reef. How does it apply to data?
It's actually a very similar concept. In biology, an ecosystem is a complex network of interacting organisms and their physical environment. In business, a data ecosystem refers to the entire, unique IT architecture of a specific entity.
So it's everything together.
Right. It's the physical infrastructure, like the servers, the software, the programming languages they choose to use, the specific databases, and the storage technologies used to collect, analyze, and interpret data.
So Tarleton State University has its own unique data ecosystem for managing student records and grades, and a local bank has a totally different data ecosystem for managing financial transactions.
Precisely. No 2 ecosystems are exactly alike. And navigating your company's unique ecosystem requires a structured project lifecycle. You can't just run in and start coding in Python. The module highlights Harvard's Data Science Ready Project Lifecycle, which outlines 5 crucial steps.
Okay, let's test my intuition here. If I'm a manager and I need to start a data project, I assume step 1 is just scooping up as much data as humanly possible, so I have a lot to work with. Is that right?
Actually, no. That is a classic rookie mistake, and it leads to what we call data swarms, just massive pools of useless information. Step 1 of the Harvard lifecycle is sensing.
Sensing, like feeling it out.
Close. Sensing is the process of identifying what data is actually meaningful and necessary to answer your specific business question before you collect a single thing. It's defining the parameters. If you want to know why tent sales are down, you don't need to collect data on the color of your employees' cars. You have to sense what matters.
Okay, that makes sense. Figure out what we care about first. What is step 2?
Step 2 is collection. Now that you know what you need, you actually go gather that data from validated, reliable sources. This could be web scraping, pulling from internal SQL databases, or using APIs.
Right, we have the data. Step 3.
Step 3 is wrangling. This is the process of converting the raw data into a clean, user-friendly format.
Let me push back on this for a second, because this always confused me.
Yeah.
Why is wrangling a whole separate step? If I just collected the data from our own sales database, shouldn't it already be ready to use? Why do I have to wrangle it?
That is the harsh, ugly reality of real-world data. Raw data is almost never clean. It is messy, unstructured, and filled with human errors. Imagine you pull customer birth dates from 3 different systems. One system formats it month, day, year. Another does day, month, year. The third system let the customer type it in manually, so some people wrote October and some people made a typo and wrote Otcoba.
Oh, I see. Python can't do math on Otcoba.
Exactly. If you feed that raw data into a predictive model, the model will break. Or worse, it will give you a confidently wrong answer. Wrangling, or data cleaning, is the tedious but vital process of standardizing all of those dates into one format, deleting the duplicates, and handling the missing values. If you don't clean it, your analysis is worthless.
Garbage in, garbage out, as the saying goes.
Exactly right. Which leads us to step 4, analysis. This is where you actually deploy your Pandas or your machine learning models to examine the newly cleaned data and find meaningful conclusions.
And the final step.
Step 5, storage. Securing, maintaining, and providing ongoing access to that data using the proper hardware and software. You have to store it safely so it can be used for the next project.
Sensing, collection, wrangling, analysis, storage, the 5 steps of the Harvard lifecycle. So let's pull all the way back. We have the tools, Python, and its libraries. We understand the difference between the Swiss Army knife of Excel and the factory line of Python. And we have the structural framework of the ecosystem and the lifecycle. What is the ultimate goal here? Where does this all lead for someone who wants to be a CEO or a department head one day?
It all culminates in what we call data-driven decision-making, or DDDM, and the ability to communicate those decisions through visualization.
Data-driven decision-making. Break that down for me.
DDDM is defined as the practice of using verified facts, metrics, and data to guide strategic business decisions that align with organizational goals. It is the active process of taking the emotion, the ego, and the guesswork out of corporate strategy.
So instead of a CEO standing in a boardroom saying, I have a gut feeling we should open a new retail branch in Austin, Texas, DDDM means the manager stands up and says, our prescriptive analytics model shows a 40% unfulfilled demand for our products in the Austin metro area, and real estate prices are currently optimal. Therefore, the data dictates we expand.
That is exactly the difference, gut feeling versus empirical evidence. But to truly achieve a DDDM environment, an organization can't just buy some software. They need to develop 3 core competencies across their workforce.
What are the 3 competencies?
First is data proficiency. Your staff actually needs to know how to read and interpret data. If you hand a manager a report and they don't understand what standard deviation means, the data is useless.
They need basic data literacy.
Second is agility in analytics. This is the ability of the organization to pivot and run new analyses quickly when the market changes unexpectedly. If it takes your team 6 months to build a new predictive model, you aren't agile.
And the third.
The third, and arguably the hardest, is building a data-driven culture.
I can see why that's hard. If the corporate culture doesn't actually value the data, the CEO is just going to ignore the spreadsheet and go with their gut feeling anyway, right?
Exactly. You can have the best Python scripts in the world, but if leadership doesn't trust the data, it's wasted effort. And the absolute best way to build that trust and to communicate complex data effectively to skeptical leaders is through data visualization. This is the ultimate output of all this work.
Because nobody, not even a CEO, wants to stare at a spreadsheet with 2 million rows of raw numbers.
No human brain can extract meaningful narrative from a million rows of raw data. That is why those Python libraries we discussed earlier, like Matplotlib and Seaborn, are so critical. They make creating charts, graphics, and interactive plots relatively simple. Visualization transforms a wall of numbers into a clear, undeniable story, making it much easier for stakeholders to actually see the results and buy into the conclusions.
The module outlines a specific 3-step process for visualization, doesn't it?
Yeah.
It's not just make a pie chart.
Right, it's a very intentional process. Step 1. Explore the data sets for patterns. Before you even think about drawing a chart, you need to deeply understand what narrative the data is naturally revealing.
You have to find the story before you can tell it.
Step 2. Plan for the visuals. This is where you decide what specific type of chart best communicates that specific pattern. If you are showing trends over time, you plan for a line graph. If you are showing market share, maybe a pie chart or a stacked bar chart, you have to match the visual to the message. And finally, step 3. Create the visuals. This is where you actually write the Python code to generate the graphics and fine-tune the colors and labels for presentation.
Wow, we have covered an immense amount of ground today. We started with the absolute basics of what a dumb computer program is. We moved through meal kits and factories. We explored how marketing teams scrape the web, how Fintech stops fraud in milliseconds. And we finished with how to visualize all that data to drive high-level corporate strategy.
It is a lot to take in, but this is the absolute foundation of modern business management. Understanding these concepts doesn't just make you a better analyst, it makes you a significantly more effective and dangerous leader in the marketplace.
I really hope this deep dive helped make the leap from the familiar grid of spreadsheets into the world of programming feel a lot less intimidating. You do not have to be a software engineer to leverage Python. You just need to understand its immense power, how the mechanisms work, and when to deploy it.
That's the key. It's about knowing the capabilities of the tools at your disposal.
All right, as we wrap up, I have one more favor to ask everyone listening. Please take a second to like, subscribe, follow, and share the show. But more importantly, head down to the comments section right now. We want to hear from you, and engaging with the material actually helps cement what you just learned.
We always look forward to seeing your insights and how you apply these concepts.
Here is today's discussion question. Think about a specific role, department, or industry you want to work in after graduating from the Dr. Sam Pack College of Business. Based on the frameworks we discussed today, give us one specific, detailed scenario where you would choose to use the Swiss Army knife of Excel, and one specific scenario where you would absolutely need to switch to the factory line of Python. Let us know in the comments.
And as a brief tease for what is coming next, you've seen why businesses use Python today, and we've talked about what it can do conceptually. But next time, we are actually going to open the hood of the car. Join us for Module 26 as we explore the specific programming logic, the variables, and the structural code that actually makes Python tick.
It's going to be a fantastic follow-up. So as you head out into the rest of your day, whether you're heading to a lecture hall, studying in the library, or walking into a board meeting, remember our opening scenario with the boutique shop. The business world is moving at lightning speed. The question isn't whether the data is out there. The question is, are you still trying to whittle your solutions by hand, or are you ready to build the automated factory line? See you next time on The Deep Dive.